We're going to learn a technique called logarithmic differentiation that can be used to find the derivative of some really complicated functions here, and it will save you time over using your normal product, quotient, chain rules, and so on. Now in this first example here, I have a function that already involves a logarithm, and if you wanted to find the derivative of this with the previous rules, you would go ahead and use the chain rule, ln of something is that, and then you'd have to use the quotient rule there, and then you have to use the product rule on the top, and you have to use the chain rule again on the bottom, and you'd get a gigantic mess. Now if you want to do it that way, that's fine, it's still correct, you'll still get the right answer, but it'll be much harder. However, what we can do instead is use properties of logarithms from algebra class, that of course everyone needs to have remembered. And what that is we can break up ln, where things are multiplied are going to go plus here, two different longs, and things that are on the bottom go minuses. And then we can bring powers here. It's going to be 5 ln x. Now this one, because it's x cubed minus 2, I cannot bring the 3 out. If instead it had been x minus 2 cubed, then I could have brought the 3 out, but because it's separate here, subtracting, I just leave it like that. However, square root is the same as 1/2 power, so it'd be ln 1/2 ln x squared plus 1. And so that means that once I've broken it up using logarithms, I haven't done any derivatives yet at all. But now I can take derivative of each term, and ln x is just 1 over x. And ln of x cubed minus 2 is 1 over x cubed minus 2. Then by the chain rule, derivative of the inside is 3x squared. And then minus 1/2, ln goes to 1 over that thing, times the derivative of what's inside, 2x. And you can simplify this a little bit here. 5 over x plus 3x squared over x cubed minus 2 minus the 2's will cancel out here, and we're going to be left with x over x squared plus 1. So doing it this way, I got to avoid that crazy quotient rule, product rule, chain rule, all that stuff there, and I had 3 much easier derivatives to find. Of course, this relied on you remembering your properties of logarithms. Now for my second example there, you might say, well, wait a second, I can't do it there, there's no ln, right? We can't use properties of logarithm if we don't have a logarithm. Okay, so what we're going to do is we're actually just going to take ln of both sides, x cubed plus 2. So we just apply ln on both sides here. Then we're going to go ahead and use some algebra here. First off, the cube roots on everything. So you're going to have 1/3 times ln of x to the 7 plus 3 minus 4 ln x minus ln x cubed plus 2. So you see I broke it up there with the cube root being on everything. Makes a 1/3 on everything. And now I'm going to go ahead and take derivatives of both sides. The derivative of ln y is going to be 1 over y times y prime. Then the derivative of this first one is 1/3, 1 over x to the 7 plus 3 times the derivative of what's inside, minus, and then 4 and 1/3 is 4/3 times 1 over x, minus 1/3, 1 over x cubed plus 2 times the derivative of what's inside, 3x squared. And the thing is, I'm trying to find y prime, so what I'll do is I'll just multiply both sides by y, and we're going to get y prime is y times, let's see here, 7 over 3 is going to give us 7x to the 6 over 3x to the 7 plus 3 minus 4 over 3x. It's a little unclear there. Minus the 3's cancel, x squared over x cubed plus 2. And then what is y? Go back to the beginning. It's this cube root here. So what I wanted to show you is that even if you don't have an ln in the original problem, if you see a big algebraic monstrosity like this one, you can still just apply ln to both sides and use this technique to find the derivative while avoiding a lot of messy product and quotient rules. Of course, if you have something simple like just x e to the x, it's better just to use the product rule. But this is really useful when you have a gigantic mess of algebra and you want to avoid it.